In this case, let's wait for a couple of minutes before we start it, and then start. Well, let's start with a small interaction. I'd like to know where you're hearing me from. Could you please post a name of your city? Where are you sitting right now? In common, I'm broadcasting from St. Petersburg today. Last week we have a very cold weather. It was something like 10 degrees behind ahead of zero, but it wasn't warm. It wasn't warm at all. But a few days ago, something has been changed and weather has changed, and today is quite sunny. Well, what else? I'm still don't see your I still don't see you. Could you post something in the chat? But it should be somewhere here. Oh, I see your questions. You're asking where is the chat? Oh. Well, I think that you're using a question box. It's enough. Now I could see that everything is okay. And in this case, let's move on. We have waited a couple of minutes, as I promised. And let's start now. Well, my name is Alexander Barmin, and I'm a lead software engineer at IPAN St. Petersburg. And first of all, I'd like to talk a couple of words about Java workshops you're attending right now. I know that there are many Java conferences, there are many Java workshops. For example, we have a lot of them here in St. Petersburg. And what I could say, organizer of one of the latest conferences decided to split all the talks into 3 categories. They decided to split into the introduction to some technology, useful topics for practicing engineers, and the latest one, it's hardcore. Hardcore talks are ordinarily conducted by very shining guys like Mark Reinhold, or maybe Alexei Shepelov, for example, or maybe another guys from Oracle who speak about future of Java. At the same time, we also have something like a smoothie talks. It's a very interesting talks where bearded guys in t-shirts talk about amazing tools were built with microservices. Today, I'd like to talk about things that could be placed somewhere in the middle between real hardcore and in the middle between smoothie talks. As I said, my name is Alexander Barmin. Today I'm broadcasting from St. Petersburg, and besides work on a customer's projects, I also take part in internal project as a mentor in a training center. If you have any questions, feel free to contact me by email, and you could see my Twitter on the slide as well. As ordinary, let's start with agenda. First of all, I'd like to talk about modularity. What is it and why do we need it? Next, modularity was not an invention. It was invented many years ago, and first implementation of it was based on OSGi. We'll talk about it as well. Next, Java 9 was released a few years ago, and when it was released, new ice-breaking and brain-breaking feature was introduced. It was a Jigsaw modular system. Next, we will talk about it. However, Jigsaw has some tricky and very interesting things that is called Jigsaw Layers. It's a amazing feature that allows us to split application into the parts and avoid jar hell in it. And as ordinary, we're talking about Java. It's a practice workshop and webinar today. I will show you a few examples. So, if you don't mind, let's start. First of all, I'd like to introduce you these two guys. I hope all of you have seen Back to the Future movie. And what we're going to do now is to go to the past and take a look at what was the start of the technology. And let's write a DeLorean and back to the past. Well, first of all, I'd like to talk about code complexity. Modularity, it's an answer for growing complexity. And I'd like to explain complexity in the following simplest way. On the left side, you could see lines of code. On the bottom, you could see the possible solution. And I believe you definitely remember when you wrote your first program. It was something like a hello world. It could be expressed in maybe 10 lines of code. But then, as soon as your application grows, you understand that it's necessary to split your solution into the function and then call one function to another. Next, as soon as number of function grows, it's necessary to join functions together as well. And it's possible to group them into the classes and have similar functionality together. Well, in a complex solution, a lot of problems could be used using classes. However, it's always not a best approach. And when we're talking about growing complexity, we could face the situation. Then we need to manage hundreds of classes. And in this case, we also have a solution. It's possible to use IOC containers like a Spring that allows us to orchestrate our application and manage all the parts we have. Well, but what is next? What is our solution is still growing? Well, yes, of course, you know what to do. You could use the modern build tool like a Maven or Gradle. Your integrated development environment suggests you using something like a module and split your application into the modules. However, what we should do if it's not enough? Yeah, I believe you definitely know what to do. You could split your application into the microservices. Yes, you could split one huge solution into a number of small applications and connect them using REST API. It's a great approach. It's a great solution. It's a great decision to split your application. But I hope if you try to split complicated solutions that were built during many years as ordinary we have in an enterprise, it is extremely complicated. Well, in this case, we need to try to do something else. And of course, we could split our application into the parts. We could split it into something like a Maven modules, but there is still a lot of problems. For example, first of all, it's code encapsulation. What I'd like to highlight here, I believe if you decided to use something like if you decided to use something like external library, like Commons, Apache Commons, Lang, or Apache Commons IO, you will be able to access not only string utils, but also all the internal classes that are used here. Why? Just because these classes are public, you have access to these classes. And I have one more example that most of you, I believe, faced before. it is quite simple. When I tried to find a class that could join two items together like a pair, I ordinarily found the class with the name javafx.util.pair. It's a good class, but in most cases, I don't want to be to make my code depend on JavaFX. So it should be possible to actually hide internal classes that should not be published outside of any module. Well, it's okay. In some cases, we could try to write a comment that describes that these classes should not be used outside of application, and build application using them. However, we still have a problem. It's sometimes it's necessary to split the platform into the parts. For example, we're trying to use, if we're trying to use to use Java for building an application for small device like a Raspberry Pi, it would be great to have a small runtime with only necessary dependencies. If I don't want to use a graphical user interface, why do I need to include JavaFX, Java Swing libraries into my runtime? Well, it would be great if it is possible. Well, and one of the most complicated questions here is dependency management. I believe all of you know what transitive dependencies are. It could be explained in the following way. Let's take a look into this simplified application. As you can see, it consists of two modules, like module 1 and module 2, and both of these modules has a dependencies to commons length. Module 1 has a dependency to commons length of version 1.0. Module 2 has a dependency to the commons length 2.0. And string utils could be found in a version 1 as well as in version 2. And there is an interesting point. In this case, it is possible to say that module 1 is using string util of version 1, module 2 is using string util of version 2, but the question is, what string util version is used in the whole application? Well, you could say that it totally depends on class loading strategy. It's possible to say class loader that, for example, if we run our application in something like an application server, it should be a class loader should try to load dependencies from application, then it should try to load dependencies from, for example, from application server, sleeps directory, and so on. Or in some cases, it should load dependencies in alphabetical order, so we could say that commons length of version 1 will be loaded first, and so on. But it is definitely not reliable. Well, dependency management problems, developers were working on dependency management for many years. So let's get back to the past and let's take a look how these problems were solved in 2000. Well, first of all, I'd like to highlight the following things. When huge companies and famous vendors like IBM, Adobe, Bosch, Huawei, Oracle faced this problem, they decided that it's possible to join their forces and invent something interesting. And then they created an consortium called OSGi Alliance, and they decided to invent something that allows to split application, that allows to that allows to split application into the parts, and a lot of them, for example, one by one, or maybe reload dependencies on the fly, and so on. So they decided to introduce an approach of splitting application into the parts, into the meaningful parts. And two well-known implementation were introduced. First of all, it's Equinox and Apache Felix. Equinox is a base for Eclipse. Apache Felix is a base for WebLogic, for example, and they are used in a different product as well. Equinox is also used in products that are developed by IBM, like IBM WebSphere. Apache Felix is mostly used in open source products. Well, what is OSGi? OSGi it totally depends on a point of view, but in common, OSGi it's a platform that allows to split application into the parts and manage its complexity. Why? Because it allows to hide internals. For example, if we have a number of modules, we could implicitly say what dependencies should be available for in other modules, and what versions of the dependencies this particular module needs in order to be started correctly. At the same time, it's possible to manage dependencies and deploy them easily. So if you ever use the Eclipse development environment, you should remember that it's possible to add additional modules here. It's possible to install plugins, and in some cases it works without restart of Eclipse, but in most cases Eclipse requires a restart in order to load everything correctly. Well, what else? If we're talking about OSGi, it's possible to say that it is allowed to reload modules on the fly. It's also possible to have a number of versions of a particular module. It's also possible to load modules in a lazy way. For example, if we don't need any particular module, it will not be started. And developers of OSGi platform says that it is simple, fast, secure, and so on. The idea is OSGi was a quite popular solution, and it's still used in some products, but it's possible to highlight the following solutions were built on the OSGi. First of all, if you want to build your own solution based on OSGi platform, you need to have a OSGi framework. As I said, you could take Felix or Equinox and directly embed into your code. If you want to build something that is more complicated, you could try to take OSGi-based container like a Carafe, or you could take enterprise level container like Service Mix. Well, modularity, it's all about imports and exports. What exactly it means? That when we have number of modules, some modules could export something, for example, from right to left, and in other modules should import something from left to right. And we need to have a way to describe what exactly should be imported and what exactly should be exported. Well, before I see that there is a question. In a chart, it's about complications we face when migrating an application from Java 8 to Java 9 with modules in focus. I will talk about some of them, not all of them, but yes, some of them will be highlighted when I will talk about modular system and in other GSRs were introduced with it. So, when we're talking about OSGi, it is necessary to say every module should be able to explain what classes or packages are exported and what packages should be imported in order to start with particular package correctly. And developers of OSGi platform decided not to invent a wheel, and they decided to use a manifest.mf file that is stored in meta-init directory. This file is also used to designate the main class of the application. So as you can see, in common, it's quite simple. It has a bundle, manifest bundle version, bundle name, bundle activator. We will talk about activator a little bit later. It's a special class who handle life cycle of a particular bundle. It's also possible to designate import packages. This property describes what packages should be imported from another modules to make this module work correctly. Export packages, it's about packages that should be exported outside of this and make them available for in other modules. And these three lines like meta persistence, web context path, and export EGB, it's possible to say that it's something like a legacy of Java EE platform and vendors that are working, that were working on OSGi base, because these vendors it's possible to say founders of Java EE. They were working on their specifications, so we decided to include these things into the OSGi specification as well. Well, as I said, it's possible to. As I said before, it's possible to have a lazy initialization of a particular bundle. All of these features are managed by bundle lifecycle. Bundle lifecycle is quite simple and straightforward. As soon as we install a bundle into the OSGi platform, it has a status installed. But as soon as it's installed and it tries to understand what dependencies it requires to start, and it moves to the next stage, not to the next stage. It's resolved as soon as dependencies are resolved. Well, it's possible. It's then when a particular module is stopped, it could be uninstalled and it could be started. As soon as module starts, it goes to the starting state, then resolve all dependencies, activate all the necessary callbacks, and then go to active state. So we could stop it. It goes to the stopping state and then resolved. Back, it is default state when all the dependencies are resolved and the bundle is not active. Let's talk a little bit about dependency bundle activator. Bundle activator is quite simple interface that have two methods that allows it's quite simple at this interface that allow to handle events when bundle tries to start and then bundle tries to stop. So what I could say, I promised you that we will have a code, so let's take a look into the code. I believe all of you could see my IntelliJ. And I have a question. Colleagues are asking what I mean by saying OSGi bundle, and I will definitely show it right now. But before we start, I'd like to explain the project I will show. The project is really straightforward and simple. The base of the project we're working is this amazing service. This service is called IT Subotnik City Provider. I believe all of you know that EPAM conducts us IT Subotnik workshops at least twice a year, and it is conducted in many cities. So I decided to write a simple interface that provide me with a city of with conference. And as many modules I introduce into my solution, as many IT Subotniks I have. For now, I have two modules here in my project. It's a two implementation. First implementation, it's a very simple implementation of IT Subotnik in St. Petersburg. It does really simple thing. It says hello from St. Petersburg, and also I have a second implementation like IT Subotnik in Ijevsk. It's also city in Russia. Like it does the same. It says hello from Ijevsk. What do I have here for dependencies and in my build files? Build Gradle, it's quite straightforward build file. I will talk about this part a little bit later, then I finish with another parts. So first of all, here in the service model, my build Gradle is a little bit more complicated. It has a dependency to the Java Gradle module. It also has a dependency to the OSGi module. What exactly is configured here? Actually, nothing interesting, but in details, when this goal will be called, this line export package will be added to the manifest file. And it was a question in the chat. Yes, you're absolutely right. When I talk about manifest, you're absolutely right. I'm talking about manifest.mf. It should be somewhere here. Oops. It is generated automatically, but I don't see it right now. It looks like it has been packaged like, oops, it is here. Well, you see that here in the service, I added an instruction with export package, and here it is added. You see, I put the package with name EPAM Subotnik Provider, and it is here. So it is first part. Secondly, what else do I have? As I said, I have two implementations of this interface into separated modules, and build Gradle for them are a little bit more complicated. First of all, what is designated here? I also use OSGi module, but manifest file contains a little bit more lines. First of all, it says that in order to make implementation modules work correctly, it is necessary to import package with name OSGi framework, and it's also necessary to import a package with name EPAM Subotnik Provider. The package with name EPAM Subotnik Provider is exported by the service module. Well, and you could definitely ask, why do we need to have OSGi framework here? It's because here in implementation, I have not only implementation of my interface provider, but also I have a bundle activator. Bundle activator is a very interesting thing. As I said, it handles events when context starts and when context stops. So in this case, as soon as context starts, as soon as bundle start, we should see the message starting as provider, and we should publish implementation of this interface into the bundle context. Why do we need to do it? Because we have a fourth module. First module is a service, 2 implementation, 2 and 3 are implementation, and the fourth module is an application activator. Application activator do a little bit different ways. So it asks the context. Do you have anything that implements this particular interface? And as soon as context of OSGi platform says, yes, I have something for you, OSGi context takes a reference, and it's possible to navigate through these references, take an instance of class from the context, and call our method. So it's quite interesting. It's very interesting, but let's try to run it. I believe it's quite simple. That application consists of these modules. Application is a starting point and two implementations. As many implementations we have, as more implementations of this provider we will have. As I promised before, I will talk a little bit more about this build Gradle. And before the start, I'd like to run it. It do the following thing. It's quite simple. It creates a dist repository, dist folder for me, and create a jar file for all the modules I have. It creates a jar file for application, for service, for impl SPB, for implementation, for REST. And then it copies all of them into the dist folder in order to, it allows them to be a little bit more convenient for me. So then let's proceed and let's move to the console. Because when you write code in Java, it's possible to use a console, because why not? What do I have here? Here I have a quite simple, here actually I have the same, but all the same code I have in IntelliJ. Here I have everything is the same, but also I have a Felix. Felix, it's a OSGi framework that will be used to show how it works. In order to start it, I'd like to use Java 8, and Java -jar bin felix.jar. So now I'm logged into the Felix. Felix, as I said, it's a OSGi platform. What I will do, first of all, I'd like to ask Felix, do you know what modules are registered? And then Felix said that nothing interesting is registered in me, and it's necessary to register something interesting. First of all, I'd like to install some of modules we have built a couple of seconds ago. First of all, I'd like to try to install an application. So you see that Felix said that this bundle has been installed and everything quite fine, but it also have a state installed. But when I try to start it using Felix start 7 identifier is 7, it says, well, come on, I need to have a package COM/IPAM subordinate provider, but nobody provides me. Okay, in order to have this dependency, we need to install the service module as well. What should I do in order to do it? Right, install the service bundle. This bundle has been installed. Then when I try to list all the bundles I have, Felix says that, okay, all the bundles has been installed. And then as soon as I try to start an application, it says that, okay, application bundle starting. Where this message is posted from, it is posted from here, application bundle starting. But it was not intention of this example. I also wanted to show you how to extend this solution with modules. Well, for example, I'd like to introduce a couple of additional modules, a couple of additional bundles, and bundles or plugins. And then as soon as I start them, Felix start 9. And as soon as I restart the application, Felix stop 7, Felix start 7. I see that bundle with application has been started, and also I've received a message from external bundle, from bundle with an implementation. All of these are happening in a single Java process, and as you can see, I didn't disable or restart anything. So as soon as I install one more bundle, Felix stop 7, Felix start 7, I can add a functionality to my application without restart, without anything else. Quite interesting. It looks like an almost ideal solution. Oops. It looks like almost ideal solution. However, there are a lot of problems. First of all, I'd like to ask, or maybe not to ask, but to say this. In common, we have a class identifiers. No, we also we have a class identifiers, and every class could be identified by two things. First of all, it's a class name, and second thing, it's an instance of class loader. So what it leads us to? It leads us to a very interesting thing that OSGi platform creates one class loader for one bundle, and it allows us to have very interesting thing. It allows us to reload content of a bundle. For example, new version has been published, we load new version as you've seen before, or add a new functionality to existing solution. And it's possible to drop one class loader and then use another class loader. Well, this separation into different class loaders allows to solve problem with internal classes that are exposed to from one module to another, just because by design. Because if we have a single instance of class loader in one bundle and another instance of class loader in another bundle, all the classes don't know anything about each other. It allows us to reload classes on the fly. It sounds almost amazing. We could drop a class loader, create a new one, load new version of class. Amazing. Amazing or not? I don't think so, because it's possible to build a cycle in the dependencies. As ordinary, bundle 1 depends on bundle 2, bundle 2 depends on bundle 3, bundle 3 depends on bundle 1. Okay, as soon as we could use it, as soon as we could build and image the situation, it's possible to write it in Java. Well, if we have a dependency cycle, hot reload doesn't work, just because it's not possible to drop classes that are used in other modules and provide with new versions of these classes. When we drop a class loader, it leads to quite interesting problem. It leads to the memory leak, because classes has already been loaded, and we don't only have a link to it, but these classes are in memory. If these classes are quite huge, it leads to memory leaks, and it's possible to lead a crash of runtime, just because it's possible. Well, in this case, and if you tried to develop anything with OSGi, you could definitely face the situation when your application doesn't start and say, oh, linked constraint violation. Just before it happens, just because class can't resolve its dependencies, or for example, some dependencies are provided from different bundles, and so on. So it's quite complicated to understand what exactly went wrong, and moves and rises jar hell to the next level. Well, it's possible to say that OSGi doesn't solve all the problems, and maybe then in 2000 we were not prepared. We were not ready to such complicated solution. And in this case, let's move on and let's get back to the present. Java goes to the future, and a couple of years ago, Jigsaw was introduced, but it was not a single change in the Java 9. In order to implement it, it was necessary to introduce a lot of additional changes. But we know how to introduce a change into the Java. It's necessary to have a Java enhancement proposal, or JIP. Well, guys from Oracle, from Sun, decided that it's necessary to introduce something else that could allow us to solve the problem we have in Java with modules. The first JEP about it was a JEP with number 200, modular GDK. Mark Reinhold suggested this JEP. The idea is quite straightforward. We should split our Java development kit into the parts and use for our application only that things that we need, not all we have. Next, in order to have this code base split, it's also necessary to split the code. Additional enhancement proposal was introduced. Well, as soon as we have number of modules for runtime, it would be great to build runtime images from these modules. For example, we need only module 1, 2, 3, and 8. So let's build a custom runtime with all of them, and all others will be excluded. And as soon as we're working on the refresh of JDK, it's possible to hide something that should not be used by developers, but they're using it. And it's possible to hide internal API somewhere else, just because it's possible. And what could I say? That encapsulation of internal API is the first problem when you could face when we'll move from, for example, Java 8 to Java 9. And we have a question in the chat about OSGi. OSGi, is it obsolete nowadays? No. Sometimes it is still in use. There are a lot of applications were written using OSGi. As I said, Eclipse is still using it. NetBeans is still using it. So if you try to develop a plugin for it, you have to use OSGi. And some time ago, I was working on a plugin for the tool that manage ontologies. It is called Protege. It's also built on OSGi. Yes, I could say it was quite complicated, but it was an interesting experience. So it is not totally obsolete nowadays. So what else was introduced? Okay, it is module system was also introduced, and it was introduced a tool, JLinker. JLinker is a special tool that allows to build runtime images. Well, let's take a look into these enhancement proposals. Well, it's a very interesting picture from the Mark Reinhold's Twitter. It describes the dependencies between modules in Java before Java 9. You see a lot of modules, a lot of interconnections between them. It's totally messy. And after Java 8 and Java 9, the changes have been introduced, and you could see that a lot of modules, a lot of classes were grouped together, and a lot of classes, well, they were not removed, but dependencies between them were refreshed. Regarding this picture, I could say that, for example, Java Corba has been extracted into the separated module, and in the new version of, if I'm not mistaken, in Java 11, Java Fix also was extracted separately and was excluded from the basic JDK. So this approach allows to finally remove old and legacy modules that are not used right now. Like I said, Corba Java FX, Swing, and something else. And the most interesting issue I faced here is this one. It's a Java XML bind. Jigsaw was extracted into the separate module. And it is the second problem you could face when you try to migrate from Java 8 to Java 9. It's if you try to run your application, if you try to build your application that uses Jigsaw, it says that, oh, come on, guys, I can't find the Jigsaw. And here you should include Java XML bind into your module path. Well, I have a question in the chat. Do you see any case to start a new app with OSGi? It totally depends on the requirements. If it's necessary to build a module application that will be extended with plugins, I will definitely think about it, because I know how to work with technology, and I possibly know a lot of drawbacks of it. So if possible, I could start this new application with OSGi, because why not? But on the other hand, I would like to ask my team whether they have experience in it, or maybe it's possible to use Java Jigsaw Layers to do the same, almost the same things with some limitation. I will show how to do similar things, similar extension way with Java Layers. Thank you for your question. So let's move on. Java enhancement proposal number 216. Encapsulate most internal APIs. It's a very interesting and tricky thing. Java provides engineers with tons of extension points, tons of classes that should be used in order to build your own application. For example, you have a Java package, Java X package, comsun package, and these classes contains a lot of useful things like Java lang string, Java util array list, and Oracle thinks that you should definitely use exactly these classes to build your own application, and you shouldn't use internal APIs like sun, misc, and save. Well, but I know so that there are a lot of cases where you need to use it, for example, in order to access some low-level things. But it is not a good idea to use sun, misc, and save, because when you're moving from Java 8 to Java 9, the decision was made to hide this implementation, totally hide this implementation, and don't provide engineers with access to it. Well, however, all the internal API were split into two parts, into critical internal API and non-critical internal API. Non-critical internal API should not be used also, but for now there are a lot of replacement classes for it. For example, if you're using sun, misc base 64 encoder, you should replace all the usages of it with Java util base 64. But if you're using sun, misc, and save, unfortunately, I have a bad news for you. You shouldn't use it at all, or maybe use var handles to do the same things. Well, it's one more obstacle from to move from Java 8 to Java 9 and further. But if you don't use sun, misc, and save, you are happy guy. So, modular system. In order to make a JDK modular, in order to make your application modular, it was necessary to introduce a couple of things. First of all, it was necessary to introduce a module path. All of you, I hope, know that we have a class path. Class path, it's a list of places where Java runtime tries to find your classes. But now, if we're talking about modules, Java needs to know where your modules are and try to find them. Module path could be set by the -p keyword when you start your application with Java jar, for example. You should use Java -jar minus CP and provide this class path. And now you're also able to use a Java minus jar minus P as a module path. It's also possible to try to get a list of all the modules you have. It's also one more interesting thing was introduced, modular jars. It was additionally introduced modular jar files. Modular jar files, it's almost like an ordinary jar file, but with a simple difference. I will show it. As soon as we finish with slides, I will show a couple more examples with modular jars as well. So, however, Java should be as compatible with previous version as possible. So it is possible to use old plain jars as a modular jars. And if these jars are placed in a class path, they automatically receive the name unnamed. If they are placed in the module path, they automatically became automatic module. If modular jar placed in a module path, it receives the name that is set in the configuration of this module. And if you want to use something like a Java Sun misconceived, it's still possible if you import a module with name JDK unsupported. But it's a tricky way. Well, Java linker, as I have already explained, the idea is quite simple. We have a list of modules, then we use a JLink tool, and it allows us to build our custom runtime to use only predefined number of modules we need, and don't include anything else. For example, if we don't need to have a Swing or JavaFX, we could exclude them and don't build a runtime image without them. Significantly, it is possible to make runtime more slim, but in most cases, disk space is really cheap. And if we're talking about embedded device like IoT, it's a quite hard to imagine a situation when we need to distribute our application, when we need to develop our application for IoT devices in Java. What if we're writing a firmware for coffee machine? Why not? Yes, amazing picture. So I believe I've shown you number of things, number of interesting things that should be introduced in Java, because enhancement proposal, it's just a proposal. It was not implemented before they converted into Java specification request. And two specification requests were created actually. First request has had a number of 277. It was introduced in 2006 by Alex Buckley. It was a first attempt to implement a Java modular system, but in 2016, this GSR was rejected, all the code was rolled back, and another GSR was introduced, GSR with number 376, Java Platform Module System. And based on this modular system, Jigsaw was introduced and implemented. What Jigsaw includes, what modular system includes? Oracle said that it allows us to have a reliable configuration, store on encapsulation of internal classes, scalable Java platform, just because it's possible to exclude useless modules. It also increases platform integrity and improves performance. Well, the base of all these things, it's a module info.java class. It do the same things as we see before with manifest.mf for bundles. it describes the name of our module, it describes what modules do we need to make this module work. It describes what packages are exported, what packages are exported into particular external module, what packages should be imported, what implementation of particular server we have, and what packages are available for all externals and for particular externals. So, well, let's take a hoverboard and take a look into the code. From my perspective, it's significantly more interesting. So let me check out my code. Let me do strange things. I'd like to remove everything that was compiled. Come on, git clean -df git reset hard, because sometimes it's not very interesting and it leads to some problems. Now I see the proper application, the proper workspace. What do I have now? I have the same application, but written in a little bit different way. Now my build Gradle doesn't include anything else. It's just say that I would like to use updated Gradle wrapper. Service module also has a slightly different build.gradle. It says that at least Java 9 is necessary in order to build it. What do I have either? Either I have a class provider, and also I have a module -info.java. This is very important file. This important file says that this is Java module. Actually, that's all. And this class, this file should be on the top level of all the packages you have, and it should be packaged into your jar. And then you have a jar. When you build a jar with a module-info.java file, you create a JMod. Quite simple. What do I have here? The same thing. This module info says that this module will export these all the classes from this package. In order to use it, I also have a couple of implementation. They are the same. And what is described here? This module info describes that in order to have an implementation, we need somebody who will provide us with package EPAM subordinate provider. And one more additional thing, it says that this module provide us with this particular implementation as PBS, St. Petersburg Subotnik City provider, for this interface, IT Subotnik City provider. So the same for Ijevsk, and slight and small difference here in the build.gradle. Actually, nothing interesting, but here we could say that we have a compile time dependency. We have a question, can we specify package version and model info.java? No, we couldn't. And it's not possible to control versions. It's a limitation of technology. And what do I have here? I have an application. Application says, applications module info says that it requires subordinate provider from service layer, and it says that it uses this interface. Why do we need to say this? It's quite interesting thing. My application now looks in a little bit different way. Now it's a very simple public static void main class that uses the service loader class with a static method load. What exactly it does? It asks for the Java runtime. Java runtime, do you know whether somebody provides me like a module with an implementation of this interface? It is described here that this module, app module, uses this interface. And runtime says, okay, I will take a look into the module path. and in class path as well. And if I find somebody who provides IT Subbotnik with this implementation, you will receive it. So this code is quite straightforward. It creates a stream from loader. Next, it calls the get method. Then this get method do receive an instance from the context, and then calls the provide city method in order to get the strings, and then we print all these strings. So quite simple, but quite simple. We do the same things like we have in OSGi, almost of the same things. But I'd like to highlight your attention to the following things. If you take a look into the package names, you will see that package names are different. Common pump Subbotnik provider RS, common pump Subbotnik provider SPB. But what if our dependencies have the same? What if our dependencies have the same package name? I will describe it right now, but I also have a question in the chat. Is there a method to have a transparent method call without any preparation work like service loader? Nope. We need to receive an implementation of the interface from the runtime before the call. And the second question is, can we dynamically load Java modules in runtime? Yes, and I will show it. I need a couple of, I need a few T. Oops, wrong screen. And let's move on. We had a chance to, oops, what's going on? PowerPoint, come on. Oops, yeah, we had a chance to drive the hoverboard. Let's move on. So I showed you a very simplistic application. It works in the following way. Application has dependencies, and the known issue of Jigsaw is that we couldn't manage dependency versions. As it was asked, is it possible to have different versions for dependencies? No, it is a limitation, we couldn't. Could we have the same package names in the modules? No, we couldn't. However, this situation is possible when we have the same package names in a different modules. And in Jigsaw, we have a tool that allows us to resolve this situation. It's a Jigsaw Layers. Jigsaw Layers, it's not an extension, it's a part of a module system, like a local modular system that allows us to create something like an internal module. As it said, we couldn't have split packages with the same names inside a single layer, but we could have these split packages in a different layers, and different modules could belong to different layers, and layers are able to import each other. Let's take a look into this diagram. Idea is quite straightforward. Basically, we have a boot layer on the bottom. Boot layer uses Bootstrap loader to load base classes. Then we have a platform loader. Then we have application loader that loads basic classes of our application. And then this application layer allows to create additional layers, like additional plugins. And in this case, it is possible to have layers with additional class loaders, and it's possible to have split packages in different layers. So in this case, we have a boot layer, we have a layer 1, layer 2. But this diagram shows that application uses module 1 and uses module 2. But the direction of dependencies from top to bottom. So in this case, we could have dependency, we're able to receive classes from the application in the module 1 or module 2, but in most cases, if we like to extend our application with plugins, we need to have a opposite direction of the dependencies. We need to implement something like an inversion of control. And Jigsaw Layers allows us to do exactly it. Let's try to burn once again. Maybe this time we're ready for this rock and roll. Let me switch to another branch. Oops. Let's check out, and in order to check whether everything is okay, let me do the stranger things. Git clean -df git reset -1, because if something went wrong, it is just because of the complicated and broken checkout. So now I have the same application, but now it is built. It will be run not from IntelliJ, but from in a little bit different way when I try to load the modules from jars. So what I'm going to do, I'm going to build jar files for every module I have here, and then in the application I will load all the jars I have. For example, it is ordinary situation when I have an extensions for my applications, and for example, I want to I want to introduce one more plugin into my application. Well, the approach is, the application is the same. I have the service that provides us with IT subordinate cities, but I'd like to emphasize your attention to the names of classes here, pump subordinate provider. Implementation is the same. Model info is the same. Build Gradle is a little bit more interesting right now. What do I see here? Additionally, for all the modules I have here, I add this compiler option. This compiler option allows to build jar independently and say that all the classes, all the modules you could find in class path use a module path. It's a very simple thing that allows me to build these modules into the separated jars without problems with dependency resolving. So what I'm going to do right now is to start the build. This build script does the same thing. It removes all the files in this directory, build the jars, and copy jars there. You could see all of them are here. Now, let's take a look into the app module. Now you could see nothing interesting here, and module info is the same, but application class is slightly different. What it does right now, start point is here. Let me collapse it. What it does a very simple thing. It creates a map with path and module name. Path and module name. Now I have two modules here, with implementation. If you have more modules, you could create a lot of them. You could use class, for example, directory scanner for retrieving all the dependencies you have, and so on. It doesn't matter right now. What it does next? Next, it navigates through all the layers and create a layer. What layer is? Layer is created from the path of module finder. Module finder will try to create a layer from a particular jar. Next, I say that this module could use parent layer in my particular case, it's a boot layer, the lowest layer have, in order to try to create a configuration and resolve the module with predefined name in common. It takes a look into this, it takes a look into the jar and try to find the module in the jar, nothing else. And all you could, and next, as all the modules in jar are found, then they will be interpreted as a separate modules and a separate layers. Quite straightforward. What I do next, as soon as I find all the modules I need, I load, using the service loader, I load the IT Subotnik provider from this particular layer, and then ask to print the city name, nothing interesting. So in common, I have a list of jar files and modules in them. Next, in my particular case, I create a layer from the layer, one module. And next, I ask for implementation of this interface in the particular layer. I could have number of modules that provides me with this interface in a particular layer, but now I have only one module in one layer. But approach is the same. Create a layer, use a service loader, and load not from all the context, but from module layer. Yeah, unfortunately, it's almost all the things I wanted to show you. And what could I say in the conclusion? OSGi was a nice try. It was a great technology. It's still a great technology that allows us to build an extensible application, but it has a lot of building problems. It allows us to create circular dependencies. Hot bundles reload doesn't work all the time. It's necessary to remember the startup orders. If we have a cycles in dependencies, bundles will not start. I faced this obstacle many times. But what do we have now? We have Java modules, and I could say that it's our future. We have to work with it because we need to move to the next versions of Java. It's the total, and what left uncovered with my slides. It's a modular system really allows us to hide implementation and internal classes. As I said, we could use module info, and it definitely allows us to define what packages should be exported outside. All the packages that are not listed in the export line are not exported, and we couldn't access them even via reflection. And it allows us to build a better architecture if we're building our application from scratch. Just because we need to think about straight structure, about hierarchy of modules we have, and in common, it solves jar hell problems. So guys, see you in the future. Thank you. Unfortunately, I could say I'd like to ask Irina and Natalia, do we have a how much time do we have? I see that I run out of time.
I think we still have about 10 minutes if you need to answer a question or either.
Okay, let me ask a couple of questions. Could you please share your demo project repos after the presentation? Yes, I could. And more likely they will be published on the events portal, and you could find all of them in my GitHub account, and it is somewhere here. github.com, and if you take a look here, you will find a couple of interesting things, and my talk from the previous tech, from my other tech talks. a lot of branches, different projects and different branches. OSGi is for application level modularity, while the goal of Jigsaw is mostly about the modular runtime. I could say that it's also possible to build an application. It's also possible to use a Jigsaw and Jigsaw Layers for build modular application, but in common, I couldn't say that I have a lot of experience building module application in production because it's because there was no necessity to build such extensible solution. Just for me, I had some experience working on pet projects with modular system. But if necessary, it's also possible, it is still possible to build an extensible solution with a Jigsaw Layers. But OSGi is a little bit more mature from my perspective than Jigsaw. But it's a little bit more mature, but in what could I say? But in future, it's from my perspective, it's better to use tools that are provided by platform. So if possible, it's better to use Jigsaw because it is more strict. It is more strict than OSGi because OSGi doesn't allow us to say to solve all the problems. It doesn't allow us to hide internals. And from my perspective, and not only to solve all the problems we have with internal classes, but also what is more important, it allows us to solve problems with transitive dependencies. So if you ask me, I'd like to start a new application with Jigsaw Layers. Well, colleagues, unfortunately, I don't think I have more time to spend with you. So thank you for your time. It was really interesting question in the chat. And I hope my slides were also useful for you. So thank you. If you have any questions, feel free to contact me by email. And bye. See you next time.